gala evening yesterday. My name is Dan Münster. I'll be chairing this morning's session, which is about HD video and video conferencing. Our first speaker this morning is Michael Wellings from the University of Washington. He's in Seattle, presenting remotely via H323 video conferencing. It's midnight in Seattle, so Mike's been staying up late for us here. There's a 9-hour time difference. Mike is the engineering director, and he is one of the world's foremost experts on HD video. You've seen John Delaney's presentation about HD video from the ocean floor, and Mike is here to tell you how that is being done. We also saw Ann Doyle and Egon Verhaeren present on HD video, so I think Mike will give you some of the gory details of how to do that. And I'll just find Michael's slides here and give the word to Mike, please.
Okay, thank you, and good morning. I actually want to hear all about the gala evening thing you had last night. That sounds interesting. Yeah, it's a little bit late here in Seattle, but I usually stay up late anyway, so it's not too big of a deal. So I wish I could be there in Italy with you, but I'm there virtually. So I'm going to talk about the Visions 05 project, and which is live HD video images from the seafloor via IP networks. And next slide, please. First, very briefly, a little bit about Research Channel, the Research Channel Consortium. These are three statements that we wrote about ourselves to try and explain who we are. Next slide. We are a fairly large consortium. This is a list of the universities that are members. And the next slide. This is a list of the non-university members. Included in there are SurfNet and RNet, and I think you see some other familiar organizations, Poznan Supercomputing Center, Microsoft Research, and so on. Next slide. So distribution, next slide. U.S. television distribution is about 22 million households for our television channel, and we also have a worldwide internet audience. Next slide. Innovations in technology. By the way, I'm going through this rather rapidly because I've got 20 minutes. Out of that 20 minutes, I think I have about 19 minutes to talk because I have a really cool HD video to play for you that tells a bit of the story of the Visions 05 project. This is why we do what we do, mainly to advance big networks for big science. Next slide. We are actually a collaboration among experts in internet networking, storage infrastructure development, emerging streaming media, interactive technologies, digital television engineering, and video production. Next slide. Projects we did the first Internet HD TV transmission, which we call iHDTV. We've just announced that we're going open source with that suite of software, and if anyone is interested in participating in that, they should contact me. We also have a digital asset management system which we wrote, which is also going open source. That's Digital Well. We do multiple webcasting experiments, streaming to handheld devices, and we run the Research Channel Internet 2 working group. Next slide. So iHDTV is our suite of high-definition over IP software. Next slide. iHD 1500 is the uncompressed SMPTE 292M422 over IP software. That's about 1.5 gigabits per second. This requires high-end capture boards, PCI Express platforms because it's necessary to use the PCI Express NICs, and Windows XP at this point in time. Next slide. iHD 270 is basically Sony HDCam over IP. We've been doing that since August of '99. That's about 270 megabits per second. It doesn't require any wild or special networking. Next slide. So recent demos, there was iGrid in San Diego, where we did two projects. One was our HD interactive conferencing system using uncompressed HD, and the other was the high definition from the SS Thompson, which I'm going to tell you about. And in November of 05, we had a demonstration running at Supercomputing 05. So next slide. This is titled, I may have been forgetting to say next slide, but we should be on the slide that says iGrid 05 USA 118.
We are.
Thank you. This was central actually to the Visions program because we used this demonstration to transmit the Visions 05 show around the world. Each remote site used three high-speed 3.4 gig Xeon machines, PCI Express platforms. And the central site equipment in San Diego consisted of 8 machines in that same configuration. Next slide. This is a network diagram which may or may not be fully readable on your screen. This diagram is available on the Research Channel website. This shows the network that was part of the Visions plus N-Way, global N-Way conferencing system. Next slide. So USA 119 was the first ever HD over IP from a ship at sea to viewers on shore. We did a satellite link from ship to shore. We had to upgrade the satellite equipment on board the ship to KU band. Had some challenges, RF engineering challenges to design the link budget, satellite link budget to get the data rate to shore. We did real-time MPEG-2 main profile at high-level encoding, that's high-definition encoding. We had an IP gateway, so we extended the University of Washington network all the way out to the ship. We ran a satellite modem at about 15 megabits per second over this link. And we used the USA 118 iGrid demo as our transport vehicle for the live show. Next slide. This is a diagram developed by John Delaney's group which shows the pieces involved in the demonstration. You see the JSON ROV down in the lower left-hand corner of the screen. There's a fiber optic cable that extends from the JSON up to the SS Thompson, and then from the Thompson, the satellite link to Galaxy 10R, which is a Pan-MSAT satellite. That's the one that our uplink is pointed at all the time, and it was easy enough for us to use that same satellite for this IP link. Downlink was to Seattle, Washington, University of Washington, and then we used the network to disseminate the video to multiple locations, Australia, the Netherlands, various other locations at uncompressed rates. We also transported the HD video by Windows Media HD at 720p and MPEG-2 at 20 megabits per second. Both of those were multicast feeds. We also supplied a failover to a unicast feed on the Windows Media 720p stream. So those were live as well. Next slide. So engineering HD from the ocean floor. Next slide. The challenges were the satellite transmission link budget, so the location on the globe, the amount of power we could have on board the ship, the amount of bandwidth we had available to us on the satellite link, and of course the ship's schedule. The HD underwater camera took a while to get this thing, and there's only one outfit that makes them, and it took quite a bit of time to have it built especially for us, and we ran up against several problems in having it delivered on time before the ship departed shore. And then we were doing a live production at sea, and that was also exciting. Next slide. Here's the location. You see the field called Endeavour. That's where the ship was. And there's a picture of the SS Thompson. Next slide. This is the drawing of the camera. It's in a titanium housing. That is a 3-chip high-definition camera encased in a very high-pressure housing that can withstand the high pressures and horrible environment that you get at 3,000 meters depth. Next slide. This slide is, I'll have to take my glasses off to read this one. This is the this is the diagram of the network on board the ship and the gear it took to do this. Up in the upper right corner you see a little picture of the satellite antenna. The Jason with the camera on board it down in the lower left. And basically the production gear and the what we call glue devices to convert from digital to analog to component analog to serial digital and back and forth to carry all of the signals from on board the ship all the way back to shore. In addition, we had a live television camera. I think you see it up in the center of the top of the screen. A live HD camera which was shooting pictures of John Delaney and the crew inside the ship as they were doing their science. Next slide. This is the satellite footprint of Galaxy 10R. Each one of those contours is rated in at EIRP, that's effective isotropic radiation, and you can see 50, 49, 48, 46. Those are DBI references. So we predicted that this would probably work because we knew about where the ship was going to be, but until it got there, we had no idea how much data we would get across this satellite link. And in fact, this is a predicted satellite footprint. It was printed up before the satellite was ever launched. I'm not sure that Pan AMSAT went out in the ocean to see what kind of RF levels there were out there. But now we know. Next slide. Inside that radome is the 2.5 meter KU band antenna, which is mounted on servos and gimbals to keep it pointed at the satellite. Next slide. That's a picture of the inside of it. You see the KU band antenna strapped to the back of the, the amplifier. It's a 40-watt amplifier strapped to the back of the KU band antenna. This thing is able to remain pointed at the satellite in seas so rough you'd have a hard time standing up. It's really pretty amazing. Next slide. There is the underwater camera. That's John Delaney lifting it by the front end and getting his fingerprints on the lens. And next to him is one of my staff engineers, Dave Robertson. Dave spent about 2 months on board the ship trying to get this stuff set up. Next slide. There is the Jason, and down in the lower right you see the camera before it was mounted on board the machine. Next slide. And there's the mounting. We weren't able to do anything wild with pan tilt motors on the thing. We were lucky enough just to get the space on the Jason, so they had to kind of point it straight ahead and hope that it really got pictures of what we wanted to get pictures of. Next slide. This is Dave Robertson at the production control room that we built on board the ship. Those are 2 IP phones. Those were actually on the campus switch over the IP network. So it was really cool. We had this whole IP network directly attached to the university by satellite. Next slide. There's the production crew on board the ship talking to John. And the next slide. This is the diagram of the gear for USA 119. It's a fairly simple diagram, and it gives you an idea of the signal path over the satellite link. May or may not be readable, but we had 2 separate carriers. We had the video carrier at 15 megabits, and then we had some email traffic at, I think, 2 megabits or so. We brought those signals back into the University of Washington, into our main studio. We wrapped a live television HD show around that. And then we transported that over the network through the Pacific Northwest Gigapop down to iGrid, where we then sent it out at uncompressed rate at 1.5 gigabit, multicast, to each one of those locations you see listed on the lower right. And then in addition to that, we had multicast viewers watching at Windows Media HD at 5.6 megabits per second, that's 720p, and MPEG-2 HD, which was 20 megabits per second. By the way, if anyone is interested in seeing any high-definition video of Seattle, I do have 2 services up and running, and at the end of the talk, if you remind me, I'll give you the IP addresses of those, and if you have a network fast enough, you can watch them. They're up 24 hours a day. Next slide. This is the network diagram of that demonstration, including the satellite link in between, and the network on board the ship, the routers involved. Again, quite a lot of detail, but this diagram is available on the Research Channel website, and also I believe you can download this slide set and probably take a closer look at the diagram. Next slide. So some follow-on goals, pending funding, of course. We shot about 155 hours of tape, high-definition videotape on board the ship. We did about 3 hours of live transmission, but 155 hours were recorded to tape. And the goal is to store that video at HD cam rate in our digital well asset management system and create a metadata engine for it and make it available for researchers. It's a big project, and we're depending on John Delaney to find funding for that. But we do have a small demonstration project involving a couple hours of video, which we're scheduled to bring online, I think, by July. Next slide. So this is what we do. This is bringing science to your desktop using our IHD TV software suite. We can deliver uncompressed HD delivery for collaborative environments, uncompressed HD for demanding visual applications, like all the detail you'd want to see in underwater footage like that, such as Vision 05 and the Neptune and Looking Project and others. Also, we can deliver compressed high definition in several formats: Windows Media HD, MPEG-2, and eventually the Advanced Video Codec, or H.264 MPEG-4. They're all same name for the same, different names for the same thing. Next slide. These are the formats and the various players we're using currently. We haven't had much success with the Advanced Video Codec, basically because in software it's extremely demanding at 1080i, and there aren't very many hardware codecs out there for MPEG-4 at this point, at least at high definition rates. Next slide. So at this time, I would like to roll the video. This is a Windows Media HD 720p file. It's a 7-minute video, and it tells the story in 7 minutes of the project. So I'll stop talking and let you watch.
Think forward. Think Research Channel.
What we're looking at is trying to understand the most extreme conditions on which life can live on the planet. And the hydrothermal chimneys really exemplify. They're a great place to look at those questions because they have very, very steep gradients. The highest chimneys that we know about vent fluids at temperatures of 380 degrees C, so about 700, 750 degrees Fahrenheit. And these fluids are very enriched in volcanic gases. The technology is very challenging in these environments because in our case we're sitting down at the bottom of the seafloor. It's about 7,000 feet down from the surface. We're using a tethered vehicle, a robotic vehicle called Jason, which is connected from the ship by a fiber optic cable to a small vehicle called Medea, and then there's a fiber optic cable that goes from Medea to Jason. Jason's a great robotic vehicle. We get lots of different images right up to the ship so we can see what the vehicle's doing at the same time that it's doing it. It has 2 manipulator arms. They're mechanical arms that are, one of them has a force feedback, which means that when you use a joystick just like you would on a video game and you pull in on it, or squeeze it, you can tell how much resistance is coming up that wire from while you're doing it. So we have, the pilots have great skills about putting instruments in and out of the chimneys. The technical challenges are, one, extreme environment, very high pressure, very high temperature, and acidic fluids. So all the materials that we use have to withstand those conditions. Often, if there's fluids leaking out of the chimney walls, you don't even see the sulfide structures because there's so many animals growing on them.
In late August, seismologists, genome scientists, physicists, geologists, and bioengineers loaded temporary lab equipment onto the research vessel Thomas G. Thompson. Planning for the deep-sea exploration of the Juan de Fuca Ridge had taken over a year, and numerous ocean science agencies would collaborate by providing specialized dive equipment and testing instruments. Increasingly, the education and science communities rely on the expertise of IT specialists working in high-end networking, video, and visualization spaces.
This is the camera.
During the month-long expedition, a one-of-a-kind research tool would require a unique collaboration with the University of Washington's Streaming Media, Video, and TV Technology Group. The HD underwater camera would allow researchers to view life forms and Earth structures in a quality and resolution never seen before.
Let's see what it looks like over on the other end.
The goal was to establish a reliable high-definition video transmission from the HD camera on the ocean floor to the shipboard KU satellite, and finally to stream a high-bandwidth 20 megabit per second signal worldwide.
So what we're doing now is we're testing the network and we're bringing it up gradually to the higher bit rates so that we can see when the asymmetry in the network causes the routers to malfunction. So we're starting now at 1 megabit, then we'll bring it up a little higher. I don't know what increment Dave wants to go in. But as we go up, at some point the routers will fail and they'll be able to tell, hopefully, where that failure is taking place and fix it.
Testing and equipment installation had to be completed before the Thompson sailed.
Okay, 20. We're good.
That's it. It's working.
We got color bars.
Oh, that's a good sign. That is it. You got it.
How about a
That is
picture?
okay.
Okay. Video went away. Let's see what we're going to have. Here we go.
Oh, we have a picture. That's the camera.
Oh, wow. Look at that. Cool.
That's full HD.
Yeah.
Look, you can even see the dust on the lens. And people get really distorted as they walk across here because of that big glass dome.
Look. Hi there, Dan.
Hi, my name's John Delaney, and I'm a marine geologist, and we're at sea off the coast of Washington and Oregon.
I've been here for over 20 years, and this is the first time I've ever seen views of a structure like this. It's pretty magnificent, so it's a total gift for us right now.
Think forward. Think Research Channel.
Well, thank you for watching the video. That is a short piece that I produced for my talk at the NAB conference last month. as a byproduct of this whole Visions 05 thing and all the effort to do it, the live show that we did has been nominated for an Emmy Award, and so that's the awards being decided on June the 3rd, and so wish us luck there. That's for the whole technical team that worked on this, including my group and the group that Jim DeRost, my colleague, runs at the University of Washington, and also the network engineers responsible for building the network. So it'd be really cool if we won that. But anyway, if you'd like to look at any of this live high definition stuff that we have running, I've got a 20 megabit stream that's multicast. That can be viewed at the IP address of 233.0.73.26, and that can be viewed using an MPEG-2 player such as VideoLAN. It's about 20 megabits per second. We also have a Windows Media high definition stream available. The link to that is on the Research Channel website. If you go to our new website, you can dig through the projects area and find a couple links to it. We also have the Visions 05 hour-and-a-half show loaded up there. So I'll stop talking, and if there are any questions, I think we have a few minutes left.
Thank you, Mike. So I suppose there will be questions, and you have to wait for the microphone. Yes. Do we have a microphone in here? I guess all the AV people went away. Oh, here it is. Got a question down front.
Thank you. I'm wondering, how did you persuade Pan Am-Sat to give you that satellite uplink? It must have been horribly expensive, or did you persuade them to sponsor the event?
Well, unfortunately, we actually had to pay for it. Research Channel uses Galaxy 10R for the national broadcast of our television channel. So we already had a contract with them, and our uplink was already pointed at the thing. That made it a bit easier, and they gave us a break on the satellite time. But we actually had to buy more time than we had anticipated because of the test time required to make this work. But it all worked as predicted, so I think when we do this next time, it should be a lot easier and cheaper for us.
Okay. Thank you.
Okay. There's a question down in front here.
I'm Peter Hall from Massachusetts University.
Hi, Peter.
Hi, Mike. Basically, I wonder, how did you do the lighting down there? It's pretty dark there, the water has high absorption capacity, and you needed to get electricity down there, so it might be pretty
Right. Yeah, lighting was a challenge, especially for high definition. There are lights on tripods, and they're actually set up around the area that the researchers view. And these lights are powered they drop this big sled down there that's got a ton of batteries on it. They've also got big cables that come down from above, so they're able to power these lights that are standing on these big tripod light stands on the ocean floor. Plus there are lights on the front of the Jason as well.
Do we have a final question? Okay, in that case, I think we should thank Mike again. Thanks for staying up so late for us.
Thank you.
And the next speaker is Peter Hollup from CESNET. Peter has a PhD in informatics and works also with HD video, and he will present what they've been doing with multi-point HD video conferencing. Do we have a microphone for... Oh.
Good morning, everybody. Can you hear me? Okay. So thanks, Dan, for your introduction and for inviting me to talk to you a little bit about the high-definition video conferencing we are doing at CESNET at the Maastricht University. I'll dig a little bit deeper in what Mike mentioned regarding uncompressed high-definition video because we have developed our own system for Linux, and I'll also discuss more on network distribution of high bandwidth streams in a user-empowered way. Here you can see, or hopefully see, oh, you can see anything. Nothing. Oh, got it.
Okay, now there's nothing here, but
it doesn't matter really, hopefully. Here is the outline of my today's talk. I'll talk a little bit about video quality and high-definition video, about uncompressed HD over IP. Then I'll go for data distribution in the network and how to do it in a user-empowered way so that you hopefully don't need administrative privileges for your data distribution. I'll discuss a few demos we have done recently, and in the last part, which is just one point here, I would like to provide some feedback to the networking community who might be sitting here. From our experiences we got during last half a year, and what I think is important for future development in the networking environment. So basically, regarding Dan, would it be possible to have the image here still, because I'm kind of looking all the time to the...
Yeah. Click one time first.
I'll try.
Yeah, it's always a cycle. Can you click it?
Yeah.
Show up, I guess. Okay, click another time.
Close it there.
Just another time.
Okay, one more time.
Okay.
Did you do it?
Yeah.
I want to be able to see you and the slides together and not to speak all the time looking to the right. Okay, cool. So regarding virtual collaborative environments we are interested in, we look for the least obtrusive way how to communicate while reaching the maximum quality of natural perception, no blurred images, hopefully no artifacts in sound, as low obtrusivity of physical elements around you as possible. And for the demos I'll be talking about, we have decided to go for high-definition video with low latency, or as low latency as we can reach with the equipment we have, with multi-point data distribution without need for native multicast in the IP network. And we wanted to do an open source implementation on open source platforms and give it for free to the community. Basically, we decided to go for full high definition video, that means 1080 interlaced video, doing uncompressed 422 stream. The multi-point data distribution was based, or is based on user-empowered UDP packet reflectors. I will be digging much deeper into the data distribution. I think Philip will be talking about it more in the next session. And we developed it as a Linux-based implementation. So basically, what does high-definition video mean? It talks about high definition resolution primarily, but it also talks about refresh rate, frame rate of the video, whether the video is progressive or interlaced, about color space depth, while we are used to work with 8-bit displays per color channel, that means 24-bit. In computer systems, the video engineers are used to work with deeper color space, like 10 or 12 bits per color channel, especially when it goes to high definition video quality. About color space sampling, that means how precisely you transmit the color information, assuming that the human's eye is more sensitive to brightness changes than to color changes. So how to drop a part of the color information that is not so important for human eye and human perception. And of course, end-to-end latency of the transmission. Here, there is an image, I think it was originally created by Jeremy Cooperstock from McGill University in Montreal, regarding latency you need to reach. And it turns out that ideally you should keep yourself under 100 milliseconds to give a natural perception of transmission end-to-end. Basically, this is really hard to achieve, especially if you're transmitting the data over the Atlantic and over the US, because at that point, even the one-way delay of data distribution might go beyond 100 milliseconds. So it's really important to go as low as you can. Why are we interested in uncompressed video transmission? Basically, it gives you 2 or 3 advantages. First, it should provide minimum latency of the transmission because there is actually no processing involved on either end. Second, you get maximum video quality, which might be desirable. And third, there are less problems with artifact in the image, especially in case of loss in the network. If you use some MPEG-2 based or MPEG-4 based or even H.264 based formats, all of them are basically based on discrete cosine transform, which results in rather nasty macro blocks appearing in case that there is some problem in the network. While if you're working with uncompressed video, what images are lost, those images are just lost and you don't lose bigger parts of the overall image. On the downside, you waste bandwidth, which might be or might not be something your network engineers want, and it gives you higher demands on the processing capacity of the system that are used for transmission. This is an image you're probably familiar with. Basically, there are 2 major standards in terms of resolution with high-definition video. The smaller one, which you have seen a couple of minutes ago, is 720p. Means 1280 times 720. And the bigger one is 1080, which is 1920 times 1080. Here is what you get when you try to transmit uncompressed high-definition video. According to SMTP 292 standard, you actually use a little bit higher total resolution than the effective resolution. This is due to something called blanking lines, which I don't want to get into here. So the total resolution is 22,100 times 1125. You work with 10 bits per color channel. That means 30 bits per point in the image or per pixel. You usually work with 30 frames per second and be either progressive 30p or 60 interlaced frames or fields, sorry. And you decrease the overall bandwidth to 2/3 because of using 422 color space downsampling. Basically, if you want to preserve really maximum quality of the image in case that you work a lot with primary colors like red or blue in the image, and you want to work with full color information, you can do it with a common high-definition SDI interface, which is kind of standard in professional video processing of HD signal, and you need so-called double-link SDI. And that is called 444 color space sampling. So our system is based on transmission of the signal that's basically according to the 292 standard SMTP. And we're transmitting it, wrapping into RTP, UDP, IP stack. And it's contrary to the Mike's system we have heard of a couple of minutes ago. We use the RFC 4175, which is kind of standard how to transmit this information over the IP networks. And we require using jumbo frames because otherwise it's not possible to process it on common PC architectures. So our implementation is, as I've mentioned before, Linux-based. We had started off with ultra-grid software by Colin Perkins and Ladang Harai, and extended it with full high-definition video support. The original version supported only 720p. We are now supporting 1080i. We have optimized the software display so that there is no specialized hardware needed on the display sides. We are able to do everything in software, but it required assembly optimizations for AMD 64, and there is a number of other enhancements we have introduced. Currently, we are limited to using DVS Centaurus cards because these cards are the only ones supported on Linux platform currently, which is kind of sad because we're pretty happy with those cards except for 2 points, price and performance. Regarding price, it's extremely expensive. It's like $8,000 a piece. And regarding performance, it's not low latency card LS. They had a previous version which was able to do so-called DMA. It was even more expensive. But as it was possible to do DMA with it, it was lower latency, but this card cannot do DMA transfers. So we have to buffer at least 4 fields, resulting in at least 66 millisecond delay just on the card to get reliable high-definition video grabbing. The application workflow looks like this. Basically, you start off with some high-definition camera. You either get, if it's professional camera, you either get direct HDSDI output, or you need to have some other equipment, in our case, AJABox, to convert from analog high-definition video to HDSDI. The HDSDI gets grabbed in a computer using the Centaurus card I've mentioned. It gets processed by the ultra-grid software, and it gets piped in the network using a 10 gigabit Ethernet card, in our case, Chelsea OT 110. And on the receiving side, in case of software display, you just have a common dual AMD 64 PC with a 10 gigabit Ethernet card. And you can just connect some DVI screen like Dell display with Full HD resolution, even slightly larger than Full HD, and you can watch uncompressed high-definition stream. Regarding end-to-end measured latency, here is sort of analysis of what we have. You can see that the end-to-end latency from really end-to-end, meaning from the camera capturing till it gets on the screen, is 175 milliseconds in our current setup. And the vast majority of it is because of Centaurus buffering on the Centaurus high-definition capture card. So the interlacing, for instance, and color space downsampling, which have to be done for the software display to look nice, are just 7 milliseconds each. The overall processing in a graphics card and in the system is about 41 milliseconds. The LCD latencies, according to manufacturer specifications, is about 25 milliseconds. And the rest, about 28 milliseconds, is we attribute this to the in-camera processing when the conversion boxes and so on. So the rest of the latency. Regarding network distribution, as I've mentioned, we decided to use our UDP packet reflectors. While, for instance, Philips Group is more interested in providing a service production quality to the scientific community, we are more interested in pushing the reflectors as far as we can and trying what happens. So we have found that we're actually able to duplicate data streams up to 2 gigabits per second on AMD 64 box. So basically, we're able to duplicate high definition uncompressed stream without serious problems. The only requirement is, again, using jumbo frames. Otherwise, you will end up with too many interrupts and too many packets per second to be handled on common PC. Our reflectors are optimized for performance, though they're pretty modular, and they also support some peer-to-peer self-organizing capabilities. We have also tested optical splitters for data distribution, and I'll talk a little bit more about it in the conclusion section. In the last half a year, we had 3 demos. 2 of them were public. It was during the iGrid. It was CZ101, a high definition multi-point video conference. And the second during iGrid was US 127, which was collaborative visualization of some scientific problems. In this case, it was some collision of black holes. It's a very common problem. You will actually meet it every day. So the theoretical physicist wanted to discuss and work over some simulation of collision of black holes, and they used our software and our data distribution plane to visualize their results. The same demo as the iGrid one was shown also during the supercomputing, and basically to give you an idea how it looked like, this was the iGrid demo, and this one was the supercomputing demo. So it allowed people to both discuss in any way over the results, and it also provided the visualization transmission over the network, and the visualization was interactive so that people had some knobs to influence the visualization, to move the object on the screen, to change the time scale, and so on. Basically, returning back, the visualization and the N-Way conference connected in all cases those 3 sites, I mean San Diego, or in case of supercomputing, Seattle, then Baton Rouge in Louisiana, Louisiana State University, and Brno in the Czech Republic. The data distribution was handled in Chicago, where all the optical circuits got connected, and we had UDP packet reflectors installed in there in EVL laboratory run by Tom DeFanti and Maxine Brown. As I mentioned, we are able to duplicate, but just duplicate the high-definition traffic as of now because of maximum throughput of internal PC architecture and the buses installed in there. So we used 3 reflectors, and each of them was replicating 1 stream to all the 2 remaining sites. And the overall latency was in one part limited by our software and our end-to-end latency, and on the other hand, it was limited by the network one-way latency, as you can see here for comparison. So that's about technical, gory details of what we have done. And now I'd like to spend a couple of minutes with a few thoughts on where we are heading to and what we need from the networking community, giving hopefully some useful feedback. So basically, you can always try to increase the resolution. During the iGrid, people from Japan demonstrated compressed transmission of 4K video, meaning 4,000 times 3,000 They had some prototype of Olympus 4K camera, digital one, and they had a prototype of Sony projector. It was very nice to watch, and there are definitely many applications, for instance, in medical sciences, that can utilize such an extreme resolution. We are also playing with stereoscopic and holographic transmissions. Basically, the stereoscopic one is pretty simple. You just transmit two streams and use some stereoscopic mounted cameras and say some projectors with polarizing filters and polarizing glasses, and you can watch three-dimensional high-definition video. Also, you can work with as high-definition audio as you can. Basically, the most problems you encounter are not in the computer transmission usually, but more in the wiring problems. And incorporating another natural media like haptic feedback, for instance. If you have some simulations, you can provide it in a way known to people from gaming community, that they can get some force feedback on their devices. Of course, we would like to have more efficient reflectors. Basically, we have run a successful test of optical splitters for high-definition data transmission before the iGrid. But the problem currently is that it breaks slightly Ethernet protocol. Because if you imagine how to connect the network using optical splitters, you will end up with one channel going from source to destination that is split into multiple channels. But you have problems with the backward channels back to the source. So we could have done it during the iGrid demo, but we had problems that actually no one gives you a real lambda. Though everybody is talking about real lambdas and lambda provisioning and things like that, you actually do not get as isolated environment as we would like to have. For instance, during the iGrid, one company was showing an encryption demo, and it actually turned out that it destroyed the network for a while. And everybody was wondering what's happening. And actually what happened was that the encrypted traffic resembled ARP discovery. And the routers on the way went completely crazy. So these guys were, of course, again given Lambda service. But on the other hand, they didn't get real Lambda service, because what we do understand under Lambda service is a real dedicated path that doesn't mess up with IP and with all the protocols above. So basically, it's not very easy to get a real dedicated Lambda path that doesn't mess up with the higher levels of the TCP/IP stack. Second thing is that definitely we would like to have a reasonable control plane. Currently, if you want to establish a circuit, it usually requires calling people on the right places. During the demos, we had red phones, not to Washington, but to Chicago, to Amsterdam, and to every place which was setting up the network for us, just to negotiate when the things can be set up and so on. So basically, if we can have some integrated control planes, which we can control as a service like UCLP project from Canary, basically it would be great, and it could be integrated even with our reflectors so that we can set up both the data distribution in the optical network and the data multiplication in the network at the same time. Second important thing is quality of service. Currently, when you talk with people from quality of service, it usually comprises TCP/IP stack on the sending host, some IP layer in the network, and then TCP/IP stack on the receiving host. Basically, in our experience, it's much more complicated than that. Especially if there is some data processing in the network, you need to think about processor reservation, memory reservation, bandwidth not only in the networking subsystems but also in the storage subsystems in case that something gets stored and so on. And basically, even the problems I have mentioned regarding the encryption demo during the upgrade could have been handled by the quality of service if every switch and every router would have implemented something, some high degree of quality of service so that, for instance, ARP processing couldn't get more than several percent of the router capacity and switch capacity. So these are just a few ideas we have about networking and about feedback from our application community to the networking people. Related projects, I have mentioned UltraGrid, and Mike has also demonstrated his research channel. High definition transmission, basically they have advantage of being on a Windows platform so that they are able to utilize cheaper cards, but they don't comply the RFC, and they have just recently went to open source model. So if you are interested about more information about our system, you can just visit the website mentioned there. It's a wiki-based web where you can find the most gory details of the system, and you can also download a bootable DVD which can run our software. And it has everything installed on it. So the people who are involved in this project, and thank you for your attention. I think I'm on time, or I hope I'm on time. And if there are any questions, I'll be more than happy to answer them.
Thank you, Peter. Questions, please? Okay, Egon has a question.
Hi, thanks Peter for the very interesting talk. The question is, you extended UltraGrid. How did they respond to it? Are they using your extensions or are they...
Yes. Yes, I have talked to Ladan 2 weeks ago during Infocom conference, and she's incorporating our extensions to her code. So I think the current releases of UltraGrid is extended with our extensions. I'm not sure if it's if she has already incorporated all the extensions, but she's working hard on it.
Okay, and the second question is, unfortunately, like you said, the Centaurus card is the only one supported right now.
Yeah.
There was some talk that also other cards would come out with Linux drivers, or ones would be developed, for instance, Blackmagic Design.
Yeah.
Any news on that?
To be honest, basically only bad ones, as of now. I've talked to both Aja people and Blackmagic people, and they both said, okay, we eventually, well, it's even more complicated with Aja, because they have Linux drivers. The point is that they only provide them to OEM providers. Actually, there is one editing system based on Linux and Cinderella software, which is based on Aja Xena card. But they refuse to give out those drivers to ordinary people. And regarding Blackmagic, I got a response like, okay, we will eventually make those drivers, but, you know, nobody knows when. So, actually nothing definitive.
Okay, we'll talk to them again.
Yes. If you can support me, I'll be more than happy to reopen the issue.
Okay, is there any further questions? Well, I think that was a good idea, Egon, that maybe the community can help you and try to push the vendors to provide those drivers. And I don't know what it takes to get the OEM license, but it probably wouldn't be able to fit in with the open source model.
I'm afraid it's not compatible with open source model. Kind of, even the Centaurus drivers are not open source. And regarding the DVD, the bootable DVD I've mentioned, we were, of course, not allowed to include them. So if you buy a card for yourself, or I think we have a binary driver compiled in, but basically we were not allowed to put the source in there. But if you buy the Centaurus card, you can register on their website and download the drivers for yourself and compile them for yourself. But this is still under heavy NDA, so it's not open source anyway. In this, in the respect, with respect to the drivers.
Okay, thank you, Peter.
Welcome.
Our next and last speaker today is Philippe Galvez, who is a senior research scientist at the California Institute of Technology. Philippe has been working for many years with the VRVS system and has taken it through many reversions with continuing improving facilities, and he will talk to us today about the latest and greatest version, which is called Evo. And yeah, please, Philippe.
Yeah, thank you very much. I hope I put the mic fine. First of all, I would like to thank you, obviously, Dan and Terena, for inviting me to this conference. Yeah, I guess it didn't. One? Yeah, okay. Yeah, I was just mentioning that I would like to thank very much Dan and Terena for inviting me to this conference. So what I would try to do today is to somehow share a little bit the experience that we had the last 10 years on developing collaboration softwares and the well-known VRVS, which has been in production the last 10 years, and where we are going to. So this is a little bit the outline about what I'm thinking to explain to you, VRVS status, just to give you a quick status about what we are, what is the production systems, which is used daily by many of the physics communities. The move that we are going to do this year to move to a new architectures, new functionalities, and why we are doing that, again, leveraging our experience. And at the end, I think it would be an interesting part. It's to make a kind of demonstrations, in fact, to outline exactly what I would show on the slide. And this demonstration will be a little bit uncommon because, in fact, I would try to break the systems and show you how it can recover very, very easy. For people which are not very much aware of VRVS, so VRVS, it's a lot of reflectors, machines running on Linux softwares that we install in many places of the world. Actually, there is more than 80 reflectors worldwide in all the countries, and they're all working together and communicating each other to serve the worldwide communities. What I should point here is that for the last 10 years, our missions has been to serve science, and our users are mainly the physicists. And what we try to do when we develop these softwares is not too much to develop a new protocol or new standards, is to focus on the issues and try to find solutions. And the issues that the physics community had and still have, and will have even more in the next few years, is that there are thousands worldwide dispersed. They come from many countries, countries that can afford to buy very expensive equipment, countries that cannot afford to buy expensive equipment, and they all to work together. So we have this kind of very high requirements. Then you add the technical requirements. I need to work on Mac OS, I need to work on Linux, Windows, and this is all the issue that we have to take into account to try to find solutions to it. So the last 10 years, VRVS has been growth, and obviously you cannot do anything without the networks, and we have to work very closely with all the networks. And you can see a long list here, and I'm sure it's not fully up to date, there is much more. All the National Research Network has been involved to provide, at least on the national levels, the quality necessary for collaborative traffics. This is some statistics. As you can see, we have more than 20,000 users coming from more than 130 countries. You see kind of evolutions of the number of meetings, number of bookings on the VRVS system, which is, as I said today, the production systems for the research and many of the physicists. It's a kind of exponential growth, and there is no reason why it should stop. It will continue to grow, and if you don't plan already at this stage what will be the next architecture, then you have a big trouble, because now we will move from a few hundred or a few thousands to several thousands to millions. And you have to think a little bit about the futures. As you can see here, we have 1,400 worldwide meetings per month, again increasing, quite a lot, heavy usage. using all different type of protocol that VRBS can support, H323, MBOM, and all the different tools. And what is very interesting to note as well is that it's not used only for real-time full collaborations, it's used as well for one-to-many workshop, conference, lectures, and you see the number of these events in the beginning of this year. Few snapshots just to express you and see how it can work on the platform, Linux. It's for Windows, now it's Linux. This was one of the interesting meetings we got last year with the Ministry of Slovakia, which in fact is promoting nationally VRBS within the education and research communities. This is macOS. And this is another slide that probably most of you already seen, but it was a great experience that I had last year, being able to collaborate from a plane. It was just great. So, after giving you this kind of status where we are, and I said it's a production system, so what's next? What we have to plan for the future, and how we can use our experience from the past and even our ongoing experience for that. We all agree that it's more or less impossible, at least today, to deploy a reliable, robust RTC infrastructures. RTC meaning real-time collaborations infrastructures. And why, in fact? Why? And there's no mystery. The real-time collaborative environment, in fact, is a living entity. It's changing all the times, and we have no control of all the devices. It can start from the PCs. Everything can happen on my PCs, on my endpoint, on the node, on the networks, on the firewalls. Nobody controls it. So at any time, nobody can assure me 100% that the meeting will be going fine at a specific times, whatever effort you are trying to do. And this is a fact. Well, now the questions, not being too pessimistic, any solution for that. And this is what we are trying to work the last few years, leveraging our experience and trying to build the next generation systems. So, in fact, our solution here is to try to create a kind of living real-time collaboration infrastructure which is in fact capable of adapt to the change in real times, to the environment change, and so transparently from the end users. And this is here very challenging. Again, going back to this predictability of the collaboration tool, just to highlight where we are, it's pretty easy to connect to a server somewhere. It could be an MCU, could be multicast, but it's clear that we have no control again on all different pieces, the networks, the boxes which is in the middle, the reflectors, whatever. We don't have the control of the desktop users. We don't have the control of the networks in general. So the approach that we start to do is to say, fine, let's try to monitor all these pieces. Again, coming from the desktop environments, from the networks, from the central box, central networks as well. Let's try to get all the information that we can get from them and try to understand their status. And the second step is that as soon as you get all this information, it's easy to create a global understanding, a global view, because I gather all this information from all these different components. Now I want to have one level higher and understand what's going on these environments and how they can be interrelated each other. And this is very, very challenging. And if you manage to do that, then you start to get a kind of autonomous system that all the different pieces are related to each other and can make some actions. What's even more difficult is that, as I said before, it's easy and we have a lot of systems, a bunch of systems on the networks or available to the community today, which is based on the kind of server client architectures. You put something in the middle and you get connected. You can have 20 users, you can have 50 users, eventually 100 users. I would say, so what? We have millions. So how you manage to get this kind of scalabilities? So you have to think even larger than that, not only of your central node, it's not multiple nodes, and how you get this fully global view and get a global RTC infrastructure monitoring. Linked with the scalability factors, this reminds me a little bit when we started the internet, it was easy to connect one node to the others in point to point. Everybody was able to do that at this early age. And then it was more difficult to have 3 nodes and 4 nodes and more. We are in the kind of same state here, which is, yes, it's easy to connect few people. That's great. But then what about when you increase the numbers and you see that more or less all the key factors, scalability, reliabilities, securities, usabilities are going very down. So as soon as you start to increase the numbers, and here we speak about the internet scale or the research academic scale, it's not few hundred, not few thousands, much more. I was listening to the talk from Michael 2 days ago, and it was a great talk, and I learned a lot, and he expressed a lot of things that I think personally I like, and I agree. But one of these lessons, lesson 17, was there is nothing more dangerous than a node model applied to a new bedroom. And I cannot be more agree with that. And this is what I try to advocate the last few years. Let's change our minds. Let's make things different. Otherwise, we'll have the same mistake again, and we will never move. Taking this in axioms, so this is the kind of architectures that we try to do in Evo. On the bottom, you see what I use to call centralized architectures. The well-known is H323, but not only. Well, you have different nodes that get connected to this central point. And you have, again, no control about this node, the network to reach this node, and even the endpoint. If this node is going down, obviously everybody is disconnected. It happens sometimes, everybody is screwed. And, well, nothing you can do about that. We know that these architectures are mainly driven by the telecom companies, H320 early on, H323 after that, where they try to replicate the same protocol, the same way of thinking to the internet or on the IP networks. It works quite well. I mean, you have those low scale, you connect a few boxes, 10 boxes, everybody is happy, that's great. Well, it's not a working solution for us. On the other side, you have the full peer-to-peer type architectures, and obviously the well-known is Skype. Everybody speaks with everyone. That's great. That's fully scalable, and I think it has been a great kind of advancement on the way of thinking. But to manage the services, then it's become a problem because you have no control at all what's going on. Your PC can be used by anywhere. If you have service providers, you cannot even monitors, have a security mechanisms on the top of it. So it's not very much manageable. So what we did is to create a kind of peer-to-peer networks, overlay networks, not on the client side, but on the server side, which in fact we get in the middle a kind of full managed peer-to-peer environments, overlay networks, where the client in fact connects in point-to-point to any of them. If one of these nodes is going down, they would just reconstruct each other's and create the networks. If you lost the connectivity to one node, automatically you will be connected to another one. Completely transparent from the end users. And this is where we are moving now. So to do so, we create a software agent that we used to call Panda, just to give a name, to create this overly intelligent agent. So basically what he's doing is just, when you start, you register the high-level directory services, and he's capable of reacting any component of services that he needs to, automatic code update, continuous monitoring between all his peers. So he understands everything in real time, what's going on between him and his peer. And he got the general informations. He can reroute the traffic at any times, transparently following the network characteristics, or any change that happens on the networks. He can encrypt all the traffics, video, audio, IM, chat, anything that just cross over him. He can send alarm notifications. Something is going wrong in my node. If I have a service provider and I want to know what's going on, I get an alarm. And when you get an alarm, you can have an automatic action. Something is going on my node. Maybe I should disconnect myself to avoid to have the meetings going badly. You can provide dynamic services to whoever is capable of receiving it, because you understand the global view of the environment and keep, obviously, statistics and history. So basically, how it happens, so you connect, you start, you know wherever they are. He will register the high-level directory services. All the other members will be notified, so you get a global view of the environment. And then he will send all his monitoring information to a central place that gathers all these informations. We use the so-called Mona Lisa frameworks to do that, which is a very powerful tool developed at Caltech. So he's sending all this information, CPU, memory, networks, everything that you need to know to provide a good environment. And parallel to that, you can have a graphical user interface that can connect to these monitoring services and have a global view of your environment. One is going down, automatic routings. On the client side, you have suppose the same type of functionalities, the Java-based clients that we used to call Koala. And in fact, he's doing the same thing. He's monitoring locally what's going on your machines, having an understanding in real time about the CPU, the memory, or the information that you need to know. If you have a good audio card, video card, what type of services you can afford, what is your environment, wireless, DSL, and what type of bandwidth. Again, you get dynamically in real time what you can afford, because we know exactly what's going on your machines. Continuous monitoring to all the nodes. So if something is going wrong, if the node where you are connected for some reasons appear to not be the good one, network latency, jitters, becoming crazy, automatically we route to the best one. Alarm notifications, something is going wrong on your end node. The first level here at least will be to inform the users. Have information to the users, oh, your CPU is going crazy. Don't be worried if you lost audio. Because at least you know, the user knows, okay, fine, I understand why my audio is so crappy. Second level will say, oh, I know that your CPU is becoming crazy, I will try to fix it for you, because I understand your environment. Because it is an end client, we create some functionalities on it. You can book any meetings, you can start an ad hoc meetings, you can have a buddy list, you have all users that you can play with, you have permanent meeting rooms. Having all these collaborations, functionalities that everybody is expecting, IM presence, group, chat meetings, private meetings, firewalls and NATs, which is obviously one of the main issues when you do collaborations. So you can traverse firewalls, you can traverse NATs. If in the worst case you block UDP, he will initiate a TCP connection that most of the site opens and you can still collaborate. Can encrypt any media, video, audio, IM, chat. And so again, independently of the client that you're using, you can use an H323 device, and your audio will be encrypted as soon as you go to the networks. You can have some nice features, meeting moderators, mute, unmute, kick out participants, share files. Another part which is very important for us is the concept of plugin, because as you might have seen up to now, I didn't even speak about which clients, which video and audio clients will be running on the top of these infrastructures. And in fact, by having this plugin concept, we support any type of clients. You want to connect to Polycom device? No problems. You set up your clients and your Polycom device will be called. You want to use our advanced Evo video tool? No problems. You get it. The C clients? Fine. No problems too. This is on the video and audio clients. But not only you want to be authenticated using your own authentication mechanisms instead of using the Evo authenticate mechanisms. Fine, let's create a plugins. You put the plugins, you enable it, and you will use your own authentication mechanisms instead of. So a lot of opening possibilities. And last, obviously, because we are running a services with more than 100 countries, it has to be multi-language. We all know that we're not speaking very well all English, and there are some countries that don't speak at all English. And they need to understand what they are doing with the clients. So it should be multi-language and IPv6 compliance as it is for the futures. From the end users, what happens? You start your clients. In fact, you would call the directory services, and he will say, fine, give me the best 3 nodes where I can connect, which are the best following my locations, my network environment, and so on. And in fact, you will get the 3 best clients and dynamically monitor them, trying to understand exactly the environment and select the best one. Oh, fine, the best one that I found following my locations is this one. Right. In the meantime, it can publish in the same way the core networks publish information. You can publish some information to the monitoring services, and you can have different monitoring services. CPU, memories, latency, and so on, which in fact here, by doing so, you get a complete global view of your environments, not only from the core networks, but you go up to the end clients. And when you get this global view, you understand what's going on from these end clients to all the other end clients in the networking manners, on the environment manners, and you have a full global knowledge. And by having so, I guess you can create rules to try to fix any issue that may happen. This is how it works. So the caller just know you get the global view. Everything is encapsulated on one port. All the traffic, video, audio, IAM chat presence, control packet, and so on. You can encrypt, and everything is encrypted in the core networks. So as soon as you just reach the door to the infrastructures, everything can be protected. This is at least a GUI that we start to develop here. You see different functions, bookings, can have the usual buddy list, IAM presence, because this is obviously one function that all our users are requesting. We create the concept of communities. In the same way, we have the concept of news groups. You get your buddy list, that's great, but now you can subscribe to communities. Or I belong to the INFN communities, or I belong to the CMS physics project. You subscribe to it, which means that you get all the information from these communities, or the IAM presence of people which are already subscribed. You can invite anyone which appear on the list. You can see all the meetings going on, and so on. Automatic time zone adjustments, very important for us. Again, multi-country time zone, chat, language, and so on. Then I would like to say a very quick word as well on some very interesting and important work that we are doing as well on the client side, and we have a very knowledgeable team in Slovakia doing so, which is trying to work on the high-end video side of it, of the tool. And one of the key developments I did the last few months was this one, which is, in fact, we all know what is a C format, which is a format which is used by many all the video conferencing standards or tool. And now what we are able to do is to do the 4CIF, or more or less the VGI resolutions, using a basic camera, USB camera, and a laptop or PCs, and you have a kind of TV resolutions, very high-end. But not only, you can even send your screens up to the XGA resolutions. And you can even do more. I mean, just a question to enable it. So you don't need very expensive equipment here. You can send a TV-type resolution with the sample cameras. You can even send your entire desktop or part of your desktop. This is a way to collaborate for us. Some work which is actually going on now is to try to work on the display side of it. So we are incorporating all this video, and depending on which codec you are using, to an environment which would be OpenGL. So you can have a very nice environment, immersive environment, and different type of scenarios. Here, one thing which is important that I should point out is that everything that we are doing is, again, multi-OS platform. Work on Linux, Macs, and Windows, which is a requirement for our communities. Some Evo plans. So it has been pre-released 2 weeks ago, or a bit more, for testings. And we got already a lot of requests coming from many sides. Oh, I want to use it. How much does it cost? What is the licensing environment, and so on and so on. So we discuss about us, between us, in fact. And what we try to find a model that is workable for everyone. Our groups are funded by the Department of Energy, and is not on mandate to provide the services for the worldwide research and academic communities, and it's obvious. But in the same time, we want to have these technologies available for them, because we feel it's important. It's important for the research, it's important for the scientists and the educations. So we try to find some model where, in fact, everybody will get to win something. So the idea is to deploy it widely, largely, on the research and academic communities, whoever wants to use it, and provide the software at no cost. You get it, you use it, it's you. You have all the functionalities, you make comments, suggestions, some suggestions will be incorporated, some other. Now the next level is that, what about the support? Yes, we don't want everybody to call us every day to say, I have a problem, I have an issue, or whatever. So we are trying to find a model where, at least for people that would like to get some support, we can get some cost recovery mechanisms where at least we're not losing money, we're not losing resources. And this is what we are working on. And any feedback, comment in this regard will be very much appreciated. Yes. So, yeah, I will go very quick here. So basically where we are, so we have different types of technology, H323 world, PCs, other fancy device, even access grid for the group-to-group collaborations. And what we create here is an infrastructure that can more or less provide a full real-time, secure, self-managed environment. At this point, I would do more or less move very quick to the demonstration because I think it's important that you see it where it works. So this is the environment that will be which is working now. I will try to kill a node in the middle of the network, and we will see if we can recover. The second quick demo will be to kill a node where I am connected on, and we will see what happens. And maybe if we have time, I can try to overload my PC and see the actions. So in the not wasting time, let's move it quickly to the demonstrations. I think I have 5 minutes. Is that correct?
Including questions. Yeah.
Including questions. Okay. Let's do that quickly. So you see all my colleagues, by the way, which are actually connected here. You see the clients side of it. So they're all coming from different places, Geneva, Slovakia, here, and even California, but it's late. This is the client I was mentioning about. So you have got all these IM functionalities here. So you can invite anybody on the meetings. You can have, let's see, as I said, you either communities you want that you subscribe to, or you can even have all the list of all the other communities, following by disciplines or research networks. If I pick research network, I see everybody there. And I say, fine, I want to subscribe, open these communities, and I will be part of it, and see everybody that will be subscribing to the same communities. Language, quickly, you want Chinese, you get Chinese. We have to translate all the different pieces. You want Italians, will be Italians. If you have any translators, it will be much more interesting. You want to mute, unmute anybody's, you want to pick out anybody's, you do it. It's as easy as that. You want to share file, you upload, and you bring your meetings. But this is, let's say, the environment. On the video side, again, quickly, you get all the video, and you say everybody there. Probably they can hear us. I can say hello if I want. One thing I wanted to show you quickly is this video. Why? Because, in fact, this is a VGA resolution video here. And sent by Slovakia, so you can have a very high quality video on your own environments. But let's move quickly to the demonstration here. This is the other application, the monitoring application that give you kind of global view about the system itself. So you see all the different nodes which has been installed in many places of the world. They're all interconnected each other. You can have a zoom. And you can all monitor any of this node. I mean, you can go here and say, okay, I want to monitor the CPU, and you get the CPU plots. Everything is monitored at some point. Let's go back here. You have kind of more, let's say, logical view of all the different people on the different nodes which we are connected here. You see here, so you get a full understanding and full monitoring between this node with the kind of quality factors, networking quality factors between all these nodes, as well as from the end users to the node. So what I can try to do here is just to click this node or stop this node. Let's see here. Let's try to. Okay, so if I start this node, which is in fact running in Ukraine, actually, so what's happened? Well, we'll see. So we got a full disconnection of the backbone. And this is usually a kind of catastrophe, because you got two islands, everybody is disconnected, two sides of it, and nothing is working. As you have seen here, it took a few seconds for the entire environment to recover. So you find a kind of peer environment, peer roots, which in fact is calculated in real time using the minimum spanning tree, which always finds the best tree following the best network environment. And everybody is back. So I got a glitch of 2 seconds. What's happened if you don't try node using whatever technology, go down? Well, you have nothing to do, just go back to drink a coffee. The next quick test, and I can even choose to start it just to show you how you will recover the tree. Okay, he's back here. He will just subscribe himself to the core networks, and automatically he will be connected. Okay, the next quick test would be to, before the questions, and will be my last, is to disconnect the node where I am, in fact. So automatically my clients discover that I am in Italy, in fact, connect me to the INFN folder where I am here. So what I will do now, I will just disconnect this node, which will be the worst thing that you want to do because you are connected on. Let's try to do that. So I disconnect this node, and you will see here, after a few seconds, you will detect that, in fact, I'm disconnected. I lost all my video. I don't know what's going on. And after a few seconds, you recover again. Oh, my video here. So I've been reconnected to the Panda in real terms. So automatically I'm here, and I've been reconnected to it. Well, I think I should stop here because I'm going over time, but I think you got the ideas and definitely questions.
Okay, thank you, Philippe, for a very nice presentation and a very impressive demonstration as well. So let's do a few quick questions before the coffee break. There's one in the back.
Yeah. Hi. I'd like to ask if it's possible to connect to the presence using accounts which are not in the VRVS, but they are in either in the institutional directory or in some other presence server. Like, I mean, I have a Google account and
right.
Rome.
So, yeah. So having this environment in place now, which is a purely networking layers on the collaboration spaces, and as I was mentioning on the plugin side of it, now we have all the architectures, all the facilities to create additional modules where you can interoperate. Could be either with the video clients and a different protocol, or the different IAM protocol and different environment as well. And it will not be, I mean, in the architectural manner, it's not an issue to do that. Is it working now? No, because we have to know which one we want to be connected on. Do we want to develop these modules? Why not?
And another small question. Assuming that I would like to send an MPEG-2 stream, okay, because I'd like to higher definition collaboration scenario. So are you going to multicast the stream between the nodes, or are you going to send this to every node?
No, it just sends the streams where you need to send it. Okay. Meaning that if you are connected in Italy, and there is nobody elsewhere that wants to listen to these streams, you will stuck in Italy. But if suddenly someone in France or in US decides to join your meetings while you're actually sending, then automatically you will discover the best path to reach these end users.
Yeah, but if there are a lot of users in France, and I am in Italy, in Sicily, how many streams are going to this France?
It will be one.
Oh, okay.
One, and the guys in France will get distributed
Okay,
streams.
thank you very much.
Okay, another quick question perhaps? No? Okay, everyone wants coffee, I guess. Please, can I just remind you to fill in the online evaluation forms? And today, there will be lunch, but not for all of you. So lunch is only for those people who are signed up for one of the workshops or task force meetings. So please just remember that. Okay, let's thank all the speakers of this session.
Thank you. So I got you good knowledge now a bit about where we are.
So this external authentication method you mentioned, is anyone using that outside of, I mean, are they...
No, so actually, I mean, as it is now, as it is developed, we're using the Evo type authentications.
Yeah.
But yeah, I was mentioning about the plugins here, and so we have different type of plugins that you can install.
I couldn't read.
Oh, you cannot read.
No,
Oh,
well,
yeah. It's kind of different type of plugin. We started developing, and it's part of the architecture. So you get the video, the file sharing plugins. You can have your own development, and there will be another one that would be your authentication mechanism. So I want to use mine, or I want to use yours, or I want to use someone else, whatever. So it's already built in on the architecture.
Okay, you've got a whole...
Yeah, it looks like that.
Let's start with the authentication. Are you going to have something like a Sibboleth model?
Yes. Using the main authentication mechanisms used by the research and try to... We don't have a in our community is not usually common. They don't say, okay, we want to have we know that it is in the basic environment, process environment.
Or it could be possible, you know, to have two types of authentication. I mean, like this SSO, which are, since it's web-based, then you can use all this web single sign-on.
Right, yeah, that's using another unified.
Or I mean, any of this SSO or some kind of symbolized way.
But here, I mean, the philosophy is to be able to have the users at the end decide. I want to use the one by default. I want to mine because we just have to define and develop if it's not there, it's a plugin associated with it.
However, you see that another way around. I mean, imagine that you're in a campus and like to provide because now you have the availability to go there and tour. Then what you expect to have is to have some, let's say, in the best case, I mean, 1,000 users go there and have to create a login and remember their password, another new password.
I mean, if we're all the same, I mean, everybody ate to get another account, another login, another password, because this is what we do every day.
My hardest problem is to take care of my...
This is why when you try to develop this type of software, so you have to think about that from the beginning. Otherwise, then you're stuck, because if you don't think about that, then you're...
Is there a streaming, let's say, auto plugin for that, something like that?
Yes, so we have, if I didn't show you, if I didn't have too much time, so we develop a plugin which is a video player. And everybody, I mean, what we expect is to publish API that we don't have to develop all the plugins. The community, so you want to have your own notification mechanism, you don't know exactly what you have to pay with, but can you do it? And there will be one that will be provided by people that will be the Ego plugins, and the one that itself will mean that because you don't want to have all the plugins from everywhere.
This stuff with the video, I find it's quite nice because what you'd like at some point to do is, let's say, archive a specific meeting.
So the idea here, we have a Evo video player that you can play any maybe clips or I'm using the Java Media Framework for that.
Philip, I'm disconnecting. This is okay. You said you had a problem sometimes?
No, you don't have any problem.
Okay.
That's good.
It's good that much more centralized.
Oh yeah, I mean, it's work fine if you're on a kind of small scale, you have to know very well.
Do you think that there is a certain type of coordination still needed? Yeah, you say it's all self-healing, so actually you don't need any coordination. You will need something, actually, why not? You need to, let's say the quality is not good, so you have to do something about things. And,
you have to detect it. If it's not good, you have to detect it.
And somebody has to do something about
it. With networks, this is network side level, it can be self-curing, but if it is a visual, I mean, human effect, because you don't, the echo controller is not working, then you cannot detect it. So someone has to go in there.
And let's say the whole topology, that process is fully automatic. So let's say what you say, you burn and you took it out, and then you put it in. But how does it find the path for the short path or something?
Or the node, I'm monitoring each other.
That's what it's
in fact, if you look on this,
on the links.
If you see here, which I didn't show, but let's see here. You see all the monitoring between ORs and node and then different quality factors. By doing this monitoring here,
quality factors
are based on the launching times, the jitters, and the packet loss. And you got all different quality factors, and you calculate in real time, in fact, what we call the minimum spanning tree. We say, following everything which I monitor, this is the best path between ORs and node. This is in real time. So
minimum spanning tree, that's a nice idea. Minimum spanning tree.
And we see that to connect this node to this node, this one is the best path. So there is no reason to connect Japan to US to go to France, so you would find the best way to do that. And everything is dynamic. So if you got...
have you developed this algorithm? I mean,
and the dynamism is always okay, or you need manual intervention, or it always finds, in your opinion, the correct path?
So far, it finds always the correct path, yes. The only issue you may have, and is, for example, you see one here, and I need to work on this one. this red one here, Paris, because they're blocking some port. You cannot very much monitor what's going on here. So this node cannot know very much the latency because you're doing some probing. And because you don't know it, you may end up to have Paris connected to Canton.
Oh, Martin, we hebben de memory tape. Die journalisten wisten het.
No, not the sound from the laptop. On internet is that when individuals have registered for the MCU, okay, the little servers, and then this there's a backend mechanism which sends this information to the network, and then we automatically set up, let's say, some QS stuff for those. So it will be nice. I mean, having maybe both mechanisms in tandem. I mean, it's nice to monitor your own, but it will be even better. I mean, if you let the network aware of that and make its own best. I mean, are you interested in having providing, let's say, for each node? Or because you have done it, of course. But I'd like to know, I mean, what is the, let's call it instantaneous network demand?
It's the way it will be done.
The historical explanation for choosing Lyngby for TNC2007 lies right here. In these very buildings, internet as we know it in Denmark.
All these monitoring information are published on the web services, which means that your environment, when you want to decide what your web server being, you should be able to access it, to service it, or subscribe to the service. I know exactly what I need to put in the node, what is what on the request, then I can take an action. So, meaning that this information are published, or will be published.
Will be published, yes.
They are not closed, or we can decide to put it closed, but there is no reason to do that.
So that's the point.
Yeah, so it will be, so we publish, so you will know exactly, you should know, and then you may take your own action depending on what you understand from the network.
How much time did it take to develop this?
Yeah, I printed out also for the
this idea.
Oh, it took easily €2, I guess.
How much?
€2.
Yeah. But it's a good idea. I mean, I like that. You don't have, let's say, instability. Could that happen? Or is it, do you dampen?
It's good on that because when you develop this algorithm, the first thing you should see is exactly that. Oscillations. Something going on and back and more, and then you have to work on the kind of hysteresis.
So that's part of
so you have to modulate with it and know the time when you need to change when it's happening.
So that's already a part of the whole system.
Yeah, so it's already there may be probably some tuning. I mean, it's a first kind of short. It's already used for meetings, and we may discover things. And then you tune a little bit of things.
Okay. And it's easy to fit in any H3 to 3 because there were in former times some problems with, let's say 2 years ago with H3 to 3.
No, so
but that's all solved.
It's client agnostic at some point. So you, when I have been reconnected, for example, here, if I was using an H3 to 3, the busy one that we have here, in fact, obviously I kill my node, I lost the connection. They should disappear and not disconnect. But then the difference would have been that the same way has been reconnected after a few seconds. The H323 would have received another call a few seconds later from another node and put himself on the same meeting. So he would take a few second interruptions to have the H323 having a call from the network and be again on the meetings. Kind of recovering mechanism. And we have the same thing on C because you have to work on the protocol.
Translation is part of it. The sphere of the answer. It translates all the codecs. And that's part of the server. How big is the server needed?
It's the server itself. I mean, it's 40 softwares. It's only Java-based softwares, and it's run more or less on, let's say, commercial PCs and Linux today. And you can run Java-based can even run on Windows, but we never shot Windows.
And there's no need to formally say I'm going to join. I just set up the server and make it public in some way, and then.
Yeah, I mean, because we are offering a service. I mean, at least for communities, we have to have a minimum of control in the sense that it's interesting to have a server where it makes sense on the national research networks, on the big institute, but not very much on one guy's homes because he wants to play with it, and we don't have time to play with that. I mean, because they're all busy by doing too many things. We have to modulate it a little bit.
And you control that now.
Yes, we control that.
You could also give that control to National NRAN.
what we
Frankly, let's say that because otherwise you have to control the world.
That's true. So
do
the idea
you want to
is
do that, or do we allow you to do that?
it's not very much to control the environment because we don't control the network. What we want to do on is to give national research networks for the national research. So you manage your own local environments.
So I could, as the Irish national network, I could do that.
Right. You can have it, and we want to give as much as control for your environment. You don't have to.
So the session slides are those the same that from as this morning?
As an administrator of your environment, you should be able at least to get all the information.
Did you download them again?
For your environment.
I did it this morning.
Or ideas to be the upper layer.
I mean, the sessions.
Okay,
good. Okay, so it's
the coordinator.
Just show
you are needed in that.
Sorry?
You are needed in that. That super control is needed.
Yeah, because it's
super
you have to wait to it. I mean, unless you're very confident that you will not diverge. And at the end, it doesn't really what you want.
Ja, jeg har lige lagt dem ind her.
You always want to. It's like a first call. I mean,
Snak for det.
You make a repository and
det ved jeg ikke.
I'm sure that.
It's a moderator. It's not a.
If you start to be
ja, jeg ved det sgu ikke. Jo, men det bliver først, altså det bliver sidst, men hvilken række Martin skal også sige noget, og Shirley skal sige noget. Jeg ved ikke, hvornår i det forløb det bliver.
I mean, nowadays, with the current VRVS, I mean, you have to pass through, let's say, a kind of screen control for having a new. Yeah, I mean.
Hvad siger du?
The point is that if you are, let's say, a local, an NRN administrator, I mean, you'd like to maybe set up different communities inside your domain.
Where are they?
Is it because of trust that need to be maintained, or is it?
So I'll put up they're just the ones called Thursday.
Yeah, I'm not sure I understand. So
I mean,
there's a folder called Thursday on the desktop, and
request
that thing up, right?
a room. It's called HNet. After that,
all the presentations
like to deliver that to
are now in this folder.
Ministry of Education. Ministry of Education believes that we like to give
along with
another environment, different,
Harald. This is Lars. These two are Martin's. And we have Shirley. So everything is here.
Yeah.
Do you want me to move the stuff that's already done? Or?
Okay.
I mean, that would be an issue.
I mean,
it's not only national, but you can have it also international.
Do you think she needs?
Yeah. So the way, I mean, it would be a big, I mean, architectural.
No, I just want to know.
And changes and even kind of environment.
But then this is open. So what is this?
The thing which I showed here, and you may not see very well, but I was mentioning about newsgroup, and this. And no, it's very easy. I mean, you get. We maintain all these lists. We decide to have high energy physics environments groups, and we put all the experiments that we know.
But you decided to put them in there.
Right, we did it because we have to put it on the database. The same thing for the National Research Network.
I don't want to be rude. I'm Carol, sorry.
Oh yes, nice to see you there.
But we have to get some.
Yes, that's true. I don't even get a coffee, in fact. Sorry? Yes.
I had this session went very well.
Yeah, it looks like, and that's great.
I always have to see them when I get home on them. Because I never.
Yeah, you miss more or less all of them, no?
Almost all of them, yeah. Today I went into a session I really wanted to hear the Dutch police, and then they have arrested people and everything. I was in there for 2 minutes.
And then you have to leave.
Yeah.
Thank you.
Welcome.
Hi.
Yes, I know. But you will have all time after that.
Your slides are here. Already I know. Nothing can go wrong.
And we have a walkabout microphone.
Yes, there's just one thing there. When you get out here, you're in the shadow. They don't want you to sit and walk up and down here. If you flare, you won't this one here, and when you stop this, you'll see a folder called Thursday, and you'll see a file called Alvestran. No, that's actually on the screen. You're on the screen right now. Okay. You're displaying those to the whole room right now.
I know. I'm just being nasty. So, and that's the mic.
I think there is a remote, and they'll give you. Oh, you put.
I think that's the mic.
Yeah. They give you a back cut. Yeah.
They'll think it's gone. So just test this. Is this mic bad? Okay. It's not turned on yet, I think.
The sound man will be over here at some point.
At some point. I'll just sit down.
Is there a remote for the slide to change the slides? No.
There wasn't one in this morning.
Okay.
Yeah, so we just use the keyboard.
That means I'll be wandering up around on that side of the stage.
Yeah.
Well, that's fine. It's
I don't know if they have one.
Oh, it'll be the sound man here when he comes. He's not here.
I'll quickly change it.
Oh, you're broadcasting these right now. Okay.
Well,
but I'm not supposed to do anything with that.
as a session chair, you are.
Yes. Okay. So what am I supposed to do? I mean,
Are they all open?
Maybe you can leave it to the speakers, but just change it to the different presentation space.
Are you doing it that way?
Surely would at the bottom.
Brilliant.
My session was running over time. Okay, I can see it. I just want you to know this is not on the screen.
Oh, that's all right. It's that one. Yes. Follow the user. I'll change it on the other one as well.
I just noticed.
So you don't need me.
Okay.
Okay.
So what about these? They're not they've been on the train stand. Well,
Yeah, I don't think they'll be distributed because I picked up a load.
are they going to be distributed? Yeah. Why are they running? Dan brought them in. I don't know what if they're planning to have some staff give them over. If they want to give them out at the doors.
Well, yes, it would be nice, wouldn't it? At least give them out as people leave.
You had to put them on the chairs.
Do you want to learn how to use this?
I've got the No. Okay, good. But after you, there's going to be a very great need. Okay. And then you. So you just leave the slide up and then don't do your last slide, Mrs. Martin. Yeah. Don't do your last slide.
Fine. When does this thing? Just like the next demo.
Oh, just when everybody's seated, then you can escape and you can put up the first
I should have practiced this, I guess.
Thursday. Thursday.
Thursday, okay. Right.
And then Harold Abstract.
Okay.
It's already up in another window.
It's up in one of the windows?
So if you do the click down here, one of the windows is no presentation. If you click the down
yeah,
sure.
That one.
Okay, no problem. There is no problem. Is this? Yep. Thank you. The microphone is now working.
This was slideshow.
Are you going to keep that on?
Yeah, I think so. And I like to know where it is. I'll turn it off for now.
Trying to be rude and attack you, because this is very inelegant. People sitting there. Maybe I'll take them off. So how was it now?
Right, where are you going to stand? Are you going to put them behind that?
People are late in coming down. Well, some of the sessions ran late this morning. My session ran very late, well, the one I was attending. That was one with the commission.
Oh.
So we didn't really want to.
You didn't really want to stop these.
They were telling me about their plans and so on.
This is the guy, I forget his name. What's the name of the guy from the commission?
Well, there's Mario Campolano. And then there's also one from the research director called Erwin Hebo. So they both gave interesting presentations.
I think it's Mario I've talked to a few times.
Yeah.
one is in Denmark. The next time you'll be having all of the guys, both the local organizers and
Yeah, that's true. For some reason, there wasn't so many people interested in hosting the 2007. Suddenly, things were running late, and there had to be a decision made in order to start the preparations, because some things should have had to start pretty early. It's the logistics to work out. So,
the earlier you start, the better deals you can get for yourselves. And of course, you want to tell everyone here that next time we'll meet in Copenhagen.
Yes. But for next year, well, the year after that, 2008, we have 3 competing offers. So that's going to be a hard decision. But it's a good thing there's an interest in hosting it. I mean, it is a lot of work. I mean, the country hosting it.
Just one little, as you're the last one to say, okay, goodbye. One logistic stuff thing. Those who are also attending the GAN conference, please remember to go out and register. So you get your bag. Yes, it's always good. But later on, you should go.
Still people coming in.
They'll wander in until they'll just keep on wandering in. Just start.
So I would like to welcome you to this closing plenary session of the TNC 2006. We have a program that should start now, even though I can see people are still drifting in. I have been asked to remind you to do as it says on some of these slides, to fill in your evaluation forms. And also, if somebody here is going to attend the GAR conference, please remember to register. So much for the housekeeping announcements. Now we should start the real program for the closing plenary, and it's a great pleasure to welcome Harald Alvestrand from Norway, whom I'm sure most of you know quite well. Harald has been around for many years doing very interesting and exciting things in the internet world. He has worked for Uninet, the Norwegian NREN. He has worked for Cisco. He has been the chair of the IETF for some years. And now he works for Google in Norway. So a very warm welcome to Harald, who will talk about all the wonderful things the internet does for us and how cheap and fast it is.
Thank you. Now, good question for you. Is everyone awake? After all this long and wonderful dinner yesterday, and I'm sure that many of you have slept through this morning's program. Now, the purpose of a plenary speaker, as I understand it, are wake people up, keep people awake, and be entertaining. I'll see if I can manage that. It was with some trepidation I was watching this other plenary speaker at the beginning of the conference, because he had a talk that was kind of the opposite of mine. Very, very polished, very clearly given before, lots of high definition television and lots of science. And the one property I hope to share is entertainment. So I'm Harald Alvestad. I'm an engineer, and I work for Google. I've been a few other things in my past, like chair of the IETF, like Cisco fellow, but I kind of think that this is enough. I'm an engineer, and I do engineering. I work on networks. And there are certain things that I have learned in the world. That, for instance, you never get anything that is good, cheap, and fast. Pick two. Now, I looked at this for the internet and found, there's something wrong here. I got all three. The thing that started me going on that was this sign. It's a sign next to an junction between two roads on the highway system just east of San Jose in Silicon Valley. And it's not a major point of the American infrastructure. It's fairly important for those who drive across it every day and stand and are parked in those long lines you can see. But it's not a big thing. And I looked at the price tag of rebuilding this intersection. $142 million US. And I thought, I could buy some routers for that. So I looked around a bit and compared numbers. Okay, we got a minor highway intersection, Highway 85 to US Interstate 101, $132 million. Major internet intersection, this happens to be a Cisco Series 1, a terabit router, and the guy who's willing to sell you one is somewhere in the audience. But it costs, depending on what you ask, what options you ask for, about $4 million. That's a lot smaller number. I mean, we all know that the internet is important to the world. We prove that over and over again. I mean, Google has now become the world standard for important. So I Googled for internet and found that it was mentioned 6 billion times on the internet. That's what I call self-reference. And I was a bit fearful of being compared to John Lennon when I searched for God and found that he only occurred 443 million times. But, I mean, I knew that geeks thought that the internet is more important than sex, but I never thought that I'd prove of that. But all jokes and Google games aside, the internet is fairly important, as you can see by the wild swings of the so-called objective measures of companies' worth that we call the stock markets, where in 2001, people realized that not all of the things that people have been predicting for the internet can be true at the same time, and the lost value of the Nasdaq stock market, which is far from the overall stock market, was $4 trillion US. Now that's a large number, even compared to some of the other ones I'm going to show you in this picture. But how much does the internet actually cost to run? What's the cost of this thing? I started digging around and found that it's actually hard to say. I pulled out this little newslet from a Norwegian newspaper in Nord-Trøndelag, just north of Trondheim. The county, which is mostly rural, not densely populated, has 128,000 people. And the power company says, we can do broadband to all of these. It will only cost us $7.5 million US. And I, being a fan of pocket calculators, divided those two numbers by each other and said, okay, in this environment, in a high-cost country, in a rural environment, which is absolutely the most expensive thing you can ever wire, they could reach everyone for $60 per person. Interesting number. But you know, when you want to say how much the internet costs, you have to define what the internet is. Okay, you got wires in the ground. You got ISPs with switches that pass packets. You got companies that connect to the internet and spend lots of money wiring inside the company. You got computers inside the companies that connect to the internet that deliver service to other people over the internet, like Google. And you got the people who run the services, and you got the people who administer the people who run the services. You got the people who write the ads for the people who for the services that people run. You got the people who serve lunch to the people who write the ads for the people who run the service that run on the computers that are connected to the internet. If you want to have a very large definition of the internet, you can make it very big. But I didn't want to do that. So I looked back at, okay, let's say networks going between organizations, that is ISPs. And being an engineer, I think that the sales department is out of scope. Yeah. And so is the billing department, and the department that goes after people who do not pay the bills, and all that. I call that overhead. We just provide the internet. And I just didn't consider the services. So the problem, of course, is that data is not published in a format that fits this definition. So I had to figure out some way to get what is considered a scientific wild-ass guess as to what numbers I could use. So I looked at an ISP around that I knew a little bit about, Uninet, the academic network of Norway, because I knew where to find their annual report. Their annual report splits their expenses into, okay, this stuff goes for administration, which I don't care about. This stuff goes for other things I don't care about. And this stuff mainly goes to support networking. And it's considered a very advanced network. It's in a high-cost country. And it connects between organizations. So, do the numbers. Uninet, and I have not cleared this with Petter, so he's probably horrified at the abuse of numbers I'm doing. Uninet serves 200,000 users. The core networking infrastructure crowd in 2004 spent $4.5 million US, of which more than half was paying for the people. And I have no doubt a lot of the other stuff was also spent paying for the people, more or less indirectly. But dividing these two numbers and rounding off to the number of significant digits no larger than 1, that's $20 per user per year to provide fairly good infrastructure. Just to provide a reality check on that figure, which I'm going to use going forward, I look at residential prices for ADSL, which covers providing the infrastructure, providing the last mile connectivity, providing the billing, providing the advertising, providing the pay for the CEO. And typical prices for a low-speed internet access in the US, I mean low speed is around a megabit these days, is $150 a year. In Norway, with a different geography and different competition, they are around $400 a year. And in Korea, which is famous for its enormous uptake on broadband, it's also around $150 a year. Now, I spoke to one guy I know who used to be in the DSL business. And he said, if someone calls customer tech support and asks for help with his DSL connection, the cost of picking up that phone wipes out my profit margin for that customer for the entire year. And every minute he spends on the phone drives me into the negative. So, a major contributor for DSL cost is customer care. But of course also the last mile is an expensive problem. So, putting this stuff together, I said, okay, let's say there's 1 billion internet users out there. And let's say that the average cost of each internet user is $20 per year. What is the total cost of the internet? Well, I'm not that good at math, but if I multiply these two numbers together, I get $20 billion. By the way, I put up a picture of the most expensive part of the internet. Digging ditches. Just so you know. The world economy, total world economy, is 40,000 billion US dollar per year. That's the so-called gross domestic product of all the countries put together, according to the UN statistics. That's 2005 numbers. So, as you can see in the little diagram down in the corner, the cost of the internet is not a significant fraction of that. On the other hand, you might have noticed that the Nasdaq stock market reduction in value I mentioned for 2001 is actually 1/10 of that. So the internet doesn't cost very much, but it has an impact on the world economy completely out of proportion to its cost. Think about that for a moment. So, I promised you cheap, fast, and good. Let's see if we have some other numbers for you. You've seen this one before, I think. Back in the early days of the world, like 1989, when I started working on the internet full-time, 9.6 kilobits, the area of the little pipe you see up there, was considered a fast user connection. And if you had a backbone of 128 kilobits, you were considered to have a reasonably fast backbone. Nowadays, if you have a fast user connection, it's 10 megabits. And of course, as all of you know, who want to have a network that sends engineers drooling over and want to do work for you, a fast backbone connection is 10 gigabits, which didn't quite fit on the slide. So, it's reasonable to say that the internet is fast. However, good is a more tricky concept to wrap your hands around. Because how do you measure the damn thing? Well, you know the most difficult thing with selling quality of service on the internet? Is that the internet is too damn good. There are two events in my life where I kind of said, okay, now I know which technology is winning. One of them was at a standardization meeting for the X400 ISO standardized email service, where the organizers passed around a sheet of paper around the room and asked people to write down their email addresses. 9 out of 10 wrote internet addresses. I said, okay, game over. other thing was actually second-hand, which was a friend of mine who had been at an ITU meeting where the honored representative from Japan said, this voice over internet telephony thing is never going to amount to anything, because every week when I call my daughter in New York to talk to her, I get at least once noise on the line so that it's hard to hear. Now this lady, who was deeply wedded to the idea of telephony is a telephony thing, not an internet thing, was in fact using the very technology that she decried as could never amount to anything every week, and did not realize the inconsistency. Nowadays, of course, you all use Skype, and in fact the quality of the voice on Skype is usually better than on my telephone, which might be because I got a better headset, I don't know. But we generally operate the network with single-digit percentage packet losses, or even far less than that. Round-trip times are usually driven by the speed of light. I mean, having faster light is a major engineering project, I'm afraid. And if there are problems, they usually go away quickly. So the internet is too good for its own good. Of course, a lot of that has to do with the fact that we're over-engineering the internet. And that's a perfectly acceptable engineering solution. As Anna Stefflud used to say, what's the duty cycle on the fourth seat in your car? But a number of people are working hard to make sure that we will have congestion problems and overload problems again, including some of the folks doing HDTV. You have seen some of the presentations at this conference. So this might actually be too good to last. But at the moment, the internet is good. Now, effects of the internet. What happens when you have an infrastructure that connects the whole world, or the 1/6 of the world that presently has access, at cheap, fast, and good? Well, people communicate. People start talking to each other. People start sharing information. People start building communities that are not limited to the size of an area you can walk across in a day. This community exists because of the internet. Not just because that's what you happen to be working on, but because you are able to function as a community also between meetings, because you're able to communicate near real time, and you're able to share information across national boundaries, across organizational boundaries, and you're able to build a community across the internet. Actually, there are some, I would say, negative aspects of this increasing connectivity and increasing speed of life. It used to be that if I didn't hear about something for 6 months, no big deal. Used to be that people didn't expect to reach me every day or every night, which is worse problem. But we're speeding up life. We're making the intervals of rest shorter. I once complained to the organizers of one conference that there was no wireless coverage in the bathroom. I'm being completely addicted. But on the average, I think the increasing communication, increasing sharing, and the increasing ability to be a community is making life more fun. And of course, more fun is also good for business. I checked out some financials of some companies whose fame and fortune, or both, totally depend on the internet. Microsoft, $40 billion per year. They did business before the internet, but their current business model is totally dependent on it, even as they try to fight some of the effects. Cisco, the internet company, $24 billion a year. They couldn't do business without the internet. They power the ability of companies and users to use the internet. They're an internet company. Amazon's business is actually old-fashioned. It's called passing books around. You remember those paper things with bindings on them? They're still useful. There are billions of dollars in business in that market. And Amazon's got a chunk of it. And of course Google, $6 billion, of which most of it comes from advertising. Now advertising is an $800 billion market. So compared to all of advertising, Google is a small company. But it's an internet company. Couldn't exist. It wouldn't have even the very concept of the services it provides couldn't exist without the internet. The point is, the stuff that uses the internet is far more important than the internet itself. We spend far more money on providing the services, providing the tools, and using the tools that the internet gives us, and leveraging the internet as a way of doing business, than we actually spend on building that infrastructure. This is not the only example of small things that change the world. I kind of like this picture, which is completely incomprehensible because the font is so small you can't see the text. But it's a picture of the radio spectrum from 1 megahertz up to 100 gigahertz. And if you squint carefully and imagine well, inside that little red circle, you can see the letters ISM, which stands for Industrial, Scientific and Medical, which in radio frequency allocation speak is, within this small band, you are allowed to do anything you want. Now, it takes a fairly significant amount of imagination to get from what's written to what's actually happening. But on that single 3-letter abbreviation, we built the whole Wi-Fi industry. The fact that you at the moment have all your laptops connected to the internet without a single wire is because of those 3 letters on that chart. There's a very small allocation. If you look at all the blue stuff on the chart, that's broadcast TV. So this small thing caused the ability of wireless communication unlicensed freely and created the marketplace for the whole 802.11. Keep that in mind. Now, I wouldn't be fair to you if I claim that all is well and glory is with us and the internet will be this way forever. Far from it. There are what I call bugs in the system. One of the bugs is what I call decommoditization. The internet infrastructure is cheap, fast, and good, no matter, almost no matter who you buy it from. But people who think in terms of monopolies and control and user capture hate stuff you can buy from anyone. Because if you can buy it from anyone, there's absolutely no way to get a good profit margin on it. And as a result, you get decommoditization. You get bundled services. You get firewalls are included with this product. We protect you from the big bad internet, and by the way, as a side effect, you won't be able to run your own service. We can enhance your internet experience as long as you just run Windows. We can provide you with stuff that's just a little bit different. Different enough that once you realize that there are faster, cheaper, better ways to get the basic things you want, you find that you can't change. That's decommoditization seen from the user side. There are also a class of people I call buggy whip manufacturers. It's the same mindset as the people who realized that cars were running faster than horses. So they tried to introduce the rule that a motor car would have to have a man walking in front of it with a red flag. In the internet case, the most well written about case is the ragged rights enforcement mafia, which are saying that unless you provide us with a way to get our money in the way we are used to, we will not allow you to provide the new service you want to do. And if you try, we'll sue you into the ground. Some of it is being done by creative interpretation of existing rules, such as the idea that copyright means that you have the right to control what anyone copies at any one time. That was not the idea behind copyright. And some of it is actually trying to extend existing rights by analogy, or just because they can get away with it, to new media. The most stunning example this week was the so-called Broadcast Treaty Amendment on Webcasting that was in front of Whitehall, where, as far as I could tell, the US delegation introduced a proposal that effectively said that if anyone puts your voice up on a web as an audio file on the internet and publishes it, and they're a registered broadcaster or whatever, they own the right to put that voice snippet up on the internet in any way, shape, or form for the next 50 years. Now, that doesn't sound right. Well, at the moment, this proposal has been pulled back for further study. So it's good to keep an eye on those things, because they can come back and bite you. The internet is no longer something researchers do in the back room. The internet is being part of everybody's life every day. And the people who think in terms of legal challenges are using those tools to work on the internet. A third category that I wouldn't want confused with the other two is what I call stake claim holders, because I couldn't make the grammar come out better. If you heard about the Oklahoma land rush in the United States, the way they decided who got to own which part of Oklahoma was everyone who wanted to own part of Oklahoma lined up at the border on one specific day, and then someone fired a starting gun, and you rushed in, literally, and drove stakes into the ground around the part of the ground that you wanted to own. And if nobody had a conflicting claim, you owned it. People are behaving that way with intellectual property, patenting on the internet, on internet technologies, or on IT technologies in general, in fact. And I can't blame them. It's rational behavior given the current rule sets. But it's not good for the people. It's not good for the economy. And it's not good for the internet. Access to knowledge. Well, that's a so last year's slogan. It's going to run out of steam and that specific name, but it kind of gets the point across. Someone has to help the lawmakers and the regulators see that protecting intellectual property is a balance. It's not an either-or. More protection means more walls. Walls get in your way. Patent systems don't just give you rights. They make people afraid. If I have a bright new idea and I want to do something with that idea, I have to live in the fear, which I have no way of reassuring myself of, that someone a few months earlier thought of the same idea, filed a patent, and once the patent rolls out 3 years later, they will come back and ask me for $30 billion. I'm not kidding. We're talking about billions. The copyright paranoia, of course, makes people slow. They want to think carefully and avoid getting sued, instead of just doing what's right and what's work. And working in an environment of fear makes novelty impossible. So, in intellectual property protection, it's time to try for a new balance of power, where those who want to protect can get reasonable protection, and those who want to use can find ways to use their own ideas and other people's ideas in a fair and reasonable manner. Strike for a new balance. So, I'm almost out of slides. And I hope that I have said at least one thing that you disagree with. Because that's what makes you think. Now, the internet itself, the basic infrastructure of interconnection, has turned into a commodity a utility, and a necessity. You have to have it, or things just stop working. But the real future, the real change, the forces that will change our society, possibly beyond recognition, are the things that we use the internet for. The things that build the communities, that create the marketplaces, and makes us able to share and build upon each other's work, independent of time and space. And if we can do that, I think we can build a better world for everyone. So, you are people working in research. What researchers do is to do the next big thing, not the current big thing. I mean, we do have a need to grow the current thing bigger. Gigabits per second is not enough. And we have to build address spaces. I promised that I would mention IPv6 at least once. So there is some engineering work to be done, but basically we can just assume that the internet is there. And now it's time to figure out, so what? What can you do now that you couldn't do before? So we as a community, we as researchers, are able to use the internet in ways that can advance human society. I think that, again, our opening plenary keynote was an excellent illustration of the fact, despite the fact that he didn't talk about the internet at all. He just assumed it was there. He built upon it and used this as a tool to get the world to be a better place in his particular environment. But in order to use it, you also have to protect it. And that can be a fight. So, go boldly forth and build upon the internet.
Well, thank you very much for this original talk, Harald. And I must say you kept the time beautifully, even though we started a little late. So if there is somebody with a burning question, I guess we could take a single question or two.
The microphone is coming. Hello.
Okay, now I think it works. Yeah, thanks for your talk. One of the things which has been, I don't know if bothering me isn't really the right word, but one of the things we see around during the internet age is the virtualization of everything. Everything is getting sort of a virtual. How do you feel about it? I mean, I like to be physical even in the future. Thank you.
You know, I was once asked, why do all these network researchers have to spend all this travel budget to get together? And my somewhat flip comment that time was, well, because virtual beer tastes bad. Oh, I think you have a point in that we have to ground ourselves in the real world and realize that it's the real world that matters, so that we are real people with real feelings and real relationships and real lives and real needs. We are using the virtual as a screen upon which we project these realities. And sometimes things get easier to handle that way. I talked to one guy who spent hours and hours playing one of these massively multiplayer games. He said, the screen is useful to me because when I walk up to someone in virtual space, I'm not so afraid that he won't like me. So the virtual is a tool, and sometimes it can be a very useful tool. But I think that we need to pay attention so that we know what's real. And what's real for me is people.
Okay, we take one more at least. Over here.
Here. Two.
Well, maybe two. Depends on how long it takes.
Mike Nelson with IBM. In your previous job at Cisco, you were the chair of the Internet Engineering Task Force, which is really the best example in the world of an open standards organization that promotes open source, really has led to the development of the net and facilitated the growth that you documented. Google, unlike Cisco, hasn't been quite so clear in its commitment to open standards, and Google is not as involved in the standards process as Cisco and some of their companies. Google is clearly more prone to embrace open standards than certain other companies in Redmond, Washington. But I was curious, what is Google's philosophy on open standards, and will you be getting more involved in developing standards for things like AJAX and some of the other technologies that Google's been promoting?
As almost anything that's involved in Google, I'm working on that. But more seriously, I can't speak for Google, obviously. My impression of Google is that the whole company's business model is built upon the fact of open standards. And we got very active members in the World Wide Web Consortium. And we got people in other standards groups. We haven't yet made a deliberate effort to make those efforts visible. And frankly, with the number of things changing all the time, every day, it's hard to keep track. It's hard to get done everything you want to get done. So I'm working on that.
Okay, the final question in the front here.
Thank you. I'm Dan Munster. You mentioned that you said we should fight for the internet and the right to use it, and Mike Nelson also in his talk presented a lot of problematic areas that we should be wary of. So my question is, if it seemed very overwhelming. So my question is, if you want to recruit us as soldiers in that fight, who should we fight and how?
One thing to realize is that largely we have a war without enemies. We have people who understand the world in a different way, and people who, from their particular worldview, draw conclusions that they think are both logical, ethical, and right. They're wrong, we're right, of course. But I think, I think Mike Nelson is much better at finding out exactly where to apply the pressure than I am. And point two, I think the essence is get to the places where the talking gets done and talk to people. Don't think of it as we have to defeat the enemy. We might come to that in some cases, where we have to assemble enough power to get the people who make the decisions to feel forced to do something. But I think we have the better understanding of how the world works, and we have to communicate that understanding. So talk, and first talk to Mike.
Well, I think this was a good note to end on, so let us thank Carol once again for this closing keynote. And now it's a pleasure to welcome up here Shirley Wood, who is the Vice President for Conferences for Terena. In everyday life, she is the Customer Support Director for Ukraine, and she has been working with the Internet academic networking since 1980, so she has been a very, very good person to have in the networking conference area for Terena. And Shirley will tell us a little bit about well, this conference and what's going to happen also next.
It's always a pleasure to stand up here at the end of a Terena conference because I'm here to express my thanks to the people that have organised this event, but it's also on behalf of you. And this year's been a really good year. We've had over 500 delegates, and I've spoken to people from Brazil, from Korea, from the US, from Australia, as well as all the normal people you see from Europe. But I thought it would be useful this time to give you some idea of how much effort. No, I'll start with the aims first. Oops. The aims of the annual conference, it's the main opportunity for discussion with our community. And as I've said, this community is growing. It's wider now than Europe. It goes over the whole world. I don't know where I've got the sound from. It certainly wasn't there on my machine. It's also an opportunity for Géant 2 to actually put out information and disseminate information about what they're doing. So it's really a joint conference so that it enables Géant 2 as well as Terena to disseminate information. Who participates? Well, we've already said the national networks and their developers, users of the national networks. It's nice to see that we're seeing more users appearing at this conference. In the early days, it really did tend to be the techies. We're seeing international colleagues. I've already said people from Australia, Korea, Brazil, etc. We're seeing people from industry, Cisco, Juniper. You've seen all the exhibitors out there. The other industrial partners come because it's useful to come to this conference. They make contacts. They can do their own personal networking. And we also see policymakers and government. And again, it's useful for them because they know what we're doing, what our concerns are. So what's involved with organising a conference? Now, I know a lot of people are interested in holding the Terena conference in the future, so don't be put off by this. The conference is organised by Terena. This year it's hosted by Consortium GAR and the Catania section of INFN, and the local support's been provided by Shogun. That didn't work. It did the first one. So how many people have been involved? In Consortium GAR, we've got 6 network people. We've also involved a local firm who've done the cable and fibre laying. And that's the cable, that's the fibre that came into the conference centre just to provide you with wireless access to the rest of the world and to also bring in some video conferencing and to stream the event. On the streaming and video conferencing team, there's 22 people involved. That's an awful lot of resources, especially when you consider that GAR had to bring most of those resources and their equipment across to Catania. And obviously, when you move equipment, some of it gets lost, some of it gets mislaid when it arrives, and some of it gets damaged. So they had an awful lot of issues to deal with. Claudio tells me that's the director's desk at the back there. And I really felt for the person that put in all these sockets in every lecture theatre. But they did a brilliant job. Other people involved, we had Roberto Barbera from Catania INFN. He was doing a lot of the local organisation. Shogun, there's Alfio Romeo, Roberta, plus their huge teams. They dealt with the catering, they got you around on the buses, and they dealt with the registration here. And then there was a coordinating team which was made up of people from GAR, Shogun, Terena. So that just gives you some idea of what was involved. Now, if you're really techie, you can look at the network diagrams for what they put in here. And if you want to know more about it, please talk to Claudia afterwards, not me. I think that shows the Wi-Fi. And I'm not quite sure what that one shows. This year, we had a really good programme. Follow the user. We tried to concentrate on user applications. What encourages people to use the internet? It is now a commodity. So we've covered things like demanding applications, widening the community. We've heard about schools networking. But we've also heard about the advanced technologies, optical networks, voice and video, streaming, and also a large number of sessions on federation. So I have to say thank you to the programme committee this year. They did a wonderful job under Ingrid Mel's chairmanship. I don't know where Ingrid is. She's hiding at the back. They put together an excellent programme, and I think next year's programme committee will find it a very difficult act to follow. And I'd like to thank all the speakers and chairs for each session. They don't just come to the conference and give their presentation. They spend a lot of time beforehand putting it together and thinking about it. So thank you very much to them. And what can I say about the plenary speakers? I've only heard positive comments from everyone. John Delaney started at the conference with describing what he was doing and showing us the secrets of the deep oceans. Mike Nelson gave us an excellent talk on security and found that instead of just talking for 45 minutes, he actually had to speak for an hour and a half. And he also gave us bumper stickers. Anne Doyle, she told us she started off as a folk singer with an English degree. And now she works in high bandwidth network applications. But she showed us some very interesting dance and distributed masterclasses. Egon Verhaeren described how high-definition TV could be run over the internet. When we set up the TV last night at the dinner, I did get complaints, why wasn't it running over the internet? But I thought putting that into a palace was a bit over the top. And we've heard from Haral this morning, who said he was looking at the costs and benefits of the internet. He came up with the comments, the internet is too good for its own good. And I like this one. If you do a Google search, it shows that the internet is more important than sex. So I think we have to say thank you very much to all our plenary speakers that are still here. And we mustn't forget the sponsors, because without the sponsors, then the cost for this conference would increase. And our main sponsor was Cisco, and you can see the list of the others there. Catania is a lovely city, and we've had the opportunity to actually see a number of museums, palaces, etc., as being participants in this conference. We started off on Sunday evening with a speaker's reception on top of a museum, and we had some wonderful views of the city. Fortunately, it wasn't raining, so we could stay out on the terrace. And as you can see there, the top terrace was used for the speaker's conference. Conference Centre, the Chimenea. It's a wonderful place. It's got huge lecture theatres, lots and lots of rooms. You can easily get lost here. But it's also got a film studio and a puppet theatre, plus the amphitheatre. And that's where we held the opening reception. And we mustn't forget the gala dinner at the Palazzo Biscari last night. The interior of those rooms was absolutely amazing, and I hope you found it a pleasant experience to sit outside on the terrace and have the dinner. I'd like to actually invite a few people to come up and receive a small gift from us, and I'd like to start with Roberto Tudisco from Shogun. And she's the lady that's been rushing around trying to organise lots of things, especially when they go wrong. Thanks so much. You've done a wonderful job. And also from Consortium GAR, Federica. No? Marcella? Do you want to bring them all in? Franca and Massimo. Ever so much. You've done a wonderful job. Thank you very much. Is everyone in GAR very shy? They are very shy, otherwise we'll make Enzo come up and receive it on your behalf. You've done an excellent job. Thank you so much. It's really brilliant.
Thank you to everybody. I want to thank sorry for my bad English, first of all. And I want to thank everybody of the organization of Terena, Bert, and Caroline particularly, and all people that is here this morning, and all the staff of GAR that helped me in this difficult task.
Thank you for an excellent job. Massimo? We'll get more from you down there. Put back the side of Federica. Well done, you've done an excellent job. Oh, you're Federica.
Sorry for that.
Thank you, Claudia. Okay. I'm very disappointed you didn't turn up in a skirt. And I have to thank the Terena staff. They do an excellent job on this. They ship a lot of people over here. They make sure everything runs to time. And the one person we mustn't forget is Carol, who does keep all the programme committee and the rest of us under control. Don't do them all at once. Not yet, you don't. We haven't got to that bit. I also want to say thank you to you, the conference participants. If we didn't have you here, then it wouldn't be a conference. She's going to take my microphone for some reason. We didn't practice this, honest.
No, actually it's very symbolic. Shirley has been the Vice President conferences for 5 years. It's actually been my 5 conferences too. She's been always supportive, always positive. Shirley's style when she goes into a meeting or anywhere is, "Hi, what can I do to help?" Besides doing the organizational part of the conference as Vice President conferences, She's always been a paid-up, card-carrying member of the program committee all the years. She's gotten great people for us to serve on our program committees. Every year she's helped us build a terrific program committee. She seems to have a very convincing style, so we've just been letting her continue on to do that. But besides that, she comes to all the meetings, reviews papers, invites speakers, chairs sessions, does everything right along with the PC, which has been a tremendous help to me. And it has certainly, I think, caused the the standard of our conferences to improve greatly over the last 5 years under Shirley's very good management. Because of the close relationship that Shirley and I have had over the last 5 conferences, Dorota Olsen, the trainer president, has asked me to give Shirley a small memento to remember us by. But Bert and I got to choose the gift. So we chose something that she can probably never ever forget, the Secretariat, where she's come for so many meetings, always standing outside the door at 8:20 in the morning before a meeting, waiting for me to get there so we could get in and sit down and have a cup of tea. Shirley, thank you for everything. And this afternoon at the General Assembly meeting, unfortunately, Shirley will no longer be Vice President Conferences.
Well, let me just add a very few words. It's unusual that we give something to people who have served on the executive committee. That has not been done before, but we thought that Shirley had done such an exceptionally good job that we really ought to do something this time, and I hope you all agree with us. So let us give Shirley a hand for her 5 years.
I really didn't expect this, but thank you very much to everybody. It's a picture of the trainer offices, so I'll never forget them. But I've said thank you for this year. But I also need to say welcome to the Programmes Committee of 2007. I didn't actually tell them that I've come to the end of my term when I was asking them all to be on the Programme Committee, so I hope it's not too much of a shock for them. But I'm sure they'll find another excellent Vice President Conferences. Next year's chair is going to be Thomas Schmidt from Berlin and Hamburg. He's actually been a member of the Programme Committee for the last 2 years, so he knows exactly what is required, and he's always there putting forward his ideas and making sure everything's done on time. And this is my last slide. I'm looking forward to seeing you all in Denmark next year. I'll just be an ordinary delegate. It's the 21st to 24th of May, and I'm going to hand over to Martin.
Thank you. Can I have the mic?
Yeah.
Okay. Thank you. Have you all gotten these postcards? They used to. Boom, boom, boom. Thursday. Okay, og så skal vi se. Here we are. Wow. Yeah. Thank you. Well, I suppose you all know Denmark from one or more contexts, and the most densely populated area there in the middle, the most civilization, is Copenhagen. And if we zoom in, you can see the airport, where most of you are going to land, the city center, where most of you are going to stay probably, and north of that we have Lyngby, where the venue for the conference is. Now, Copenhagen is a lovely city. There's lots of things to see, lots of things to do. The Little Mermaid, Tivoli Gardens, and I mean, that's well known. hopefully, or will be after the conference. But what about Lyngby? Yeah, well, the real reason why we got there is because there's a local friendly university with all the necessary facilities, and it's only 15 kilometers north of the city center. And if we should have to give you an impression about what it's like there, I made this a week ago.
Hi guys.
What, I mean,
on a very nice spring day, such as this beautiful country, no matter where you go.
Just a moment. We rehearsed this. Is this it? No, sorry.
Hi guys.
Can you hear me?
On a very nice spring day, such as this, Denmark is a beautiful country, no matter where you go. But why have we just chosen Lyngby as a site for this, for the Terrain and Networking Conference 2007? I'll show you why.
The historical explanation for choosing Lyngby for TNC 2007 lies right here. In these very buildings, internet as we know it in Denmark, online internet, started with the research network in 1987. UNICE's buildings here in Lyngby are placed at one of the few university campuses we have in Denmark, the Danish Technical University in Lyngby. This is not a church, but one of the new buildings at DTU where the conference is going to take place. It has room for 550 participants, suitable for just a thing like the Terrain and Networking Conference for the opening and closing sessions. The rest of the conference, between the opening and closing sessions, will take place here in this building, where we have a lot of space for the exhibits, and we have lecture rooms, large lecture rooms, and also data facilities. Even the toilets are great. Lyngby started as a small village. You can see that with the old houses here. But you also see the modern facilities are there. In the background you see the high building, which is the biggest hotel nearby, and many of you will be staying there. So this is also Lyngby, with a nice water mill and peaceful surroundings for a stroll if you should have a 10 minutes off from the busy conference. Lyngby also has a lot of offer in the form of shops and restaurants and so on. In Denmark, mailboxes are red, and I'm telling you this because when you are here, it's so nice you want to write home to family and friends and colleagues. And for that, we've prepared this very nice postcard that you can just fill in. It's almost done, and then put it in the mailbox and get home to your friends. I have to do this myself. Yeah. Meet the camera operator of this film, my 8-year-old son, Mikkel. Now, here we are at Lyngby Station, waiting to go to Copenhagen. It takes only 20 minutes, and the train goes all the time. There we go. From Lyngby, you can go to Copenhagen, either to go to your hotel. If it's in Copenhagen, you can see all the sights, Tivoli, the Little Mermaid, whatever you like. Denmark is a nice place. Yes. So see you at TNC. Nej, vi prøver at se. So see you at TNC 2005. Nej, slutter du 2007. Yeah, okay. So see you at TNC 2007. And we also have for you not only a nice place, but of course a dedicated team of organizers. Apart from me, it will be Gitte and Linda there, and with the occasional support of Dorte Olsen, who of course will allow nothing to go completely wrong. And we have many more colleagues that are waiting just to get going for this conference. So, see you there next year.
Then we also allowed 1 minute for a presentation of the upcoming NordUnit conference.
Thank you, Martin. Well, I'm sure that after Martin's excellent and quite humorous presentation, you're all thinking, oh, but I can't wait a full year for another conference. And I certainly can't wait a year to get to wonderful Scandinavia. Well, I'm here to reassure you, you don't have to. Already, in 4 months from now, we'll be hosting, and we'll be very proud to welcome you all to the 23rd NordUnit conference, the 23rd in our series of internet conferences. And as usual, we will have technical presentations, we'll have interaction, dialogue, and as Martin showed us, this being in Scandinavia, we'll have a lot of fun. So I hope to see you all there. And just so that you have the bare facts, it will be in Gothenburg in Sweden. It will be at the end of September this year. And there's even a URL so you can all see the detail of the conference. The program is there. See you there.
So it's time to say goodbye for now. I hope that most of you, like myself, have felt that this has been a really good and fruitful conference in very nice surroundings. A lot of thanks have already been said at several occasions, but let me also finish once more by thanking everybody who has contributed to the success of this conference, the participants, the GAR team, all the local people here in Catania, and of course all the speakers. Thank you to everyone, and I hope to see you again next year for the TNC 2007.